All right, so first we want to review a little bit non-collinear, collinear. I'm not going to write the word twice here. I think there's two N's in here. Non-collinear, and that's just a simple idea. Collinear would be any set of points. It could be two. It could be three sets of points. And these points, because they lie, points that lie on the same line, we're going to call them collinear. Okay, this is like a key part to that definition. Lie on same. So they're lying, meaning they're placed. They're in that space. Remember, we talked geometry deals a lot with space. So this is the space we're talking about. The space we're talking about here is this line, and those points are on that line. Let's say you're given a triangle-shaped diagram or figure. Remember, we used the word figure here. And these 3 points, they're asking, give me points that are collinear. Let's say we have A, B, C, and D here. If I were to say which of those points are non-collinear, you would have to find any 3 points, let's say A, C, and D, right? These 3 points here, because if you take that out of the diagram, this is how the points would be lying in space. And those 3 points, there's no one line that I could draw that would contain all 3 of those points. So when you're looking for collinear and non-collinear, okay, you're looking for points on or not on the same line. Simple enough. Now, I like to review this before we take a look at going forward, coplanar and non-coplanar, because we just talked about lie on same, right? That's a key thing. Lie on same. That's a key part to that definition we just talked about. And a lot of times things that are coplanar, they talk about points, right? Points in space. Remember, point is a location in space. Points that lie on same. Now, we said previously collinear was lines, so if we're talking about coplanar, well, we're probably talking about a plane. Now, a plane is a specific surface, and I draw it on a slant to show it in its 3D fashion, specific surface in space. We're talking about a flat surface in space that we would assume is going in all directions infinitely. Okay, and if we're dealing with points on the same, that are coplanar points, if we want to talk about planar points, we're talking about points that are on the same plane, that are lying on the same plane. Meaning that if I put a point kind of floating in space here, not on this surface, this would be considered a non-coplanar point here. And you could have different examples, or they'll present to you different scenarios in which maybe you have a line that intersects a plane here. I draw these dashes to show that it's behind, okay? And you could say that, let's say I have 3 separate points. I have this point, a line and a plane intersect at one point, this point here. And let's say I put another point on this line here, okay? I could say that these 2 points, let's say A and B, I could say A and B, because they're on the same plane, I could say A and B coplanar, are coplanar. And let's say we had this point here, C. I could say C is non-coplanar. I'll abbreviate that. Non-coplanar to A and B. And now we're just kind of talking about, okay, A and B, same plane. C, how could we talk about this? All right. It would be an example maybe if you had a surface and you had two basketball players that were on that court. It's a very small court, I know, and there's a ball in the air. These two players are coplanar because they're lying on the surface of the basketball court, and that ball is non-coplanar because it's not on that surface. Now we do have some examples we want to take a look at, and when we deal with coplanar, non-coplanar, one of the things that's brought to our attention is like this rectangular solid here, this rectangular cube. And it's a little different than this kind of flat surface that we're used to talking about. Here, you're looking at 6 different surfaces. Your right side, left side, bottom, top, your front, and your back. And when you're talking about coplanar points, all of these points they're illustrating to you are on the corners, okay? So if you look at G here, like if you look at point G, just to explain the surfaces here, and I'll just do the front side. Here's G, okay? We'll go over drawing cubes. G is actually part of 3 different surfaces. G is part of it's touching the bottom surface. It's touching this side surface here, and this front surface here. Okay, so G is part of 3 separate planes. It's connected to the front, side, and bottom. Now, when you add another point to that, let's say we add point H, G and H together are only part of 2 surfaces now. G and H are part of the yellow surface and the red surface. H is no longer part of this front surface here. Right? So what do you notice? You have 2 points, and we have 2 planes. Now we know we spoke about how many points do you need to make up one specific surface. Well, we said it's 3 points that you need. So let's add that 3rd point. Let's add point D here. Now you have GHD, which are 3 non-collinear points, if you notice. And that's why we reviewed that. 3 non-collinear points. There's no one line I could draw through 3 of those. They're only part of that yellow surface, if you catch on to that. They're only part of that yellow surface there. So we've established a couple things. One, any one plane is made up of 3 non-collinear points. That is the definition of the plane. And the fact that if we're trying to find something to be coplanar, in this case, it would be these 3 points. There is one other point that we could say is coplanar, and that's also C. All we need was the third point, but you could say all 4 of these points are not coplanar, or are actually coplanar. So you can actually add the C in there. If you want to add something to be non-coplanar, maybe throw a non-coplanar point out there, well, you look at A as being non-coplanar to these 3 points. You could even say I is non-coplanar. Yes, I is coplanar to C and D, but if we were talking about just, let's say we're saying, what's a point non-coplanar to C, D, and G? So we're talking about these 3 points here. I and A are coplanar to C and D because they're part of that top surface, but not to G. G is not part of this top surface. So these would be some points. A and I would be an example of some non-coplanar points. I spelled that totally wrong. Now, what's going to happen is your guys are going to be presented with examples where you have a scenario where there's not a diagram given to you, and they're asking a line and a point not on that line are coplanar. And this is a great example. Why? Because the only way you could solve this is by drawing some sort of diagram. This problem cannot be solved without a drawing. So what I want to do is I want to take a line, and a point. These are my two objects I'm working with. 2 points make up a line, and I have a point. And now when we're talking about coplanar, we're talking about a plane. So it says a line and a point not on that line. So I have a line and a point, and this point is not on that line, are always, sometimes, and never coplanar. Well, if I could prove it to be true, and only true, it would be always. So let me draw a plane, and let me have a line on that plane. So it'd be like laying a pencil on a desk, and then a point. Are these 3 points all on this plane? Of course. So they'd be coplanar. So this is true. Now I do have to check if there is a way I could draw this diagram to be false. So let's do that. Well, let me put a point on the plane, and then let me draw this line like I did before, intersecting at a point and going through the plane, and another point here. Here I have 2 of the 3 points coplanar, but that third one non-coplanar. So I've been able to draw an instance where the 3 points are coplanar, or the line and the point are coplanar, and an instance where they're not coplanar. I could have also drawn it where the line is on that plane and the point not on that plane. So if it's both true and false, I would have to say it's sometimes. If it's only true, that would be always. If it's never true or false, I would say for that to be never. Again, more you practice this, you guys work on this, you'll get used to it. But it's the drawing part of it that's very important. It's the drawing part that's very important. Couple other examples I want to show of drawing diagrams. 2 distinct planes intersect at a pair of lines. I love this question because it just gives me the opportunity to draw what intersecting planes should look like. This way you guys can see it at any time. I'm going to draw 2 slanted lines right on top of each other. I mean right on top of each other by this point and this point basically being vertically aligned. This is how I'm going to draw my first plane here. Now my next plane, what I'll do is same premise, 2 slanted lines that are horizontally aligned. What does that mean? That means if I look horizontally across, they're kind of at the same level. So it's made up of 2 pairs of slanted lines and a pair of vertical, or we'll say this is horizontal and we'll say this is vertical, and a pair of vertical lines. And this is like 2 pieces of paper folded into each other, and like I showed you in class. Their intersection is going to be all along this edge here, all right? All along this edge. So their intersection is actually going to be a line, not a pair of lines. So, and there's no way for me to draw these 2, let's say, pieces of paper or planes intersecting at more than one line. This is where it's true, okay? But it's only true at one line. Here they're saying pair of lines, pair being 2. So this is false here, so we'll say this is never. There isn't any way I could draw two planes. What's cool too, I could show you guys right now, is actually a pair of parallel planes. Would just be drawing one plane, draw some dots here, right on top of each other. And this is an example of parallel planes. It's basically floating one piece of paper above the other. 3 points can be non-coplanar. Another little example at the end here. Yes, I could draw 3 points to be coplanar, and I could draw them to be non-coplanar. So 3 points can be non-coplanar. So we could say this is true here. Yes, they could be coplanar, but if I could draw them to be non-coplanar, we'll say this is true. You could also use that cube example we talked about and have 1, 2, 3 points in which this would be non. And then maybe I'll do in blue, I'll do 1. Actually, it's too close. Let's do a red here. And I'll show you a cool example of, let's say at 1, 2, 3 points here. These 3 points are actually collinear, coline, and coplanar. They're actually part of 2 planes, but they are in fact coplanar. And then all this stuff is just going to take some practice and hard work.